In this session, we are going to study the data that we are going to train a model with. Before we do that, we have to decide what kind of model to build and what kind of machine learning to train. The problem we are going to work on is to predict weekly sales of Walmart in the US. There are a total of 45 Walmart stores in the US. Each store has many departments. We will try to predict how much sales a week. Each department will generate. If we think about its machine learning type, among supervised learning, unsupervised learning, and reinforcement learning, it is one of supervised learning. And within supervised learning, it is a regression model. Because we intend to predict accurate sales volume in numbers. You may have heard of supervised or unsupervised learning in the earlier sessions. If you can recall it, you would understand that we need correct answers of the data for supervised learning. We have 3 sets of data for our training. Features.csv, train.csv, and stores.csv. There are 3 separate sets of data. You may wonder if we usually use one set of data to build a machine learning model. Yes, you are right. We usually use one set of data, but sometimes we have data split into sets. Sometimes data are divided. For instance, some of this data are in file A and some are in file B. We will see if we can put the data together for modeling in this case. These 3 sets of data contain the values of how much sales volume the 45 stores generated by each department and each state for 3 years from February 2010 to November 2012. That's quite a lot. We will train with this data. Each set of data looks like this. The features.csv data has a total of 12 columns. The first column shows which store location it was, and the next one has dates with 1-week intervals. And then it has the temperature of the regions where the store is located. It is included because the temperature may have influenced people's shopping behavior. There are also fuel prices. Since most people in the US drive to go shopping, higher fuel prices may have reduced the frequency of people going shopping. And we have markdowns from column 5 to 9, which contain the data of promotional events that each store held. Consumer Price Index in column 10 indicates the price ranges of daily necessities. Column 11 is the unemployment rate. If the unemployment rate was too high, consumer spending may have decreased. The last one in column 12 is holiday, which indicates if a certain day was a holiday or not. If it was a holiday, we can expect that people went shopping more, or otherwise people did less. So, it has 12 columns and 8,290 rows. The train.csv file, the second one, doesn't contain as many columns. It has 5. The first column shows which store it was. The second shows which department of the store it was. There are dates in the third, with 1-week intervals. The values in the fourth are sales of the week. Weekly sales. The last one is his holiday, which shows if the day was a holiday or not, just like the previous one. So it has 5 columns and as many as more than 421,000 rows in total. This is really a lot. This gives sales volume from all the 45 store locations every week. Each store location has up to 100 departments. So there is so much sales data built up since it's from all the departments. The last set is stores.csv. This one is very simple. Its first column shows which store location it was. The next one is the type of the store. The last one shows the size of the store. Since there are 45 stores, the stores.csv file consists of 3 columns and 45 rows. It's a very simple data. The data we are going to use can exist separated in sets like this. So we will need to put these separated sets of data together into one. How can we merge all the separate data? With what key value can we make them as one as if they had always been one? Let's try merging these two files, features.csv and train.csv. We can merge these two files by using the store and the date columns. With the store and date columns of the features.csv file as the base, the store and date columns of the train.csv file will merge the data by combining the identical parts of the both sets. After we have the merged file, we will need to merge it with the stores.csv file. We can merge them with the store column, the first one. These two jobs will merge all the data. Because the features.csv file and the train.csv file have his holiday in common, we will use only one of the both. Does the data look complex? We will try pre-processing the data first. After importing it to Azure ML Studio, we need to log into Azure ML Studio to do pre-processing. Anyone who has a Microsoft account can sign in for free and use the functions, so please sign up for an account and log in. I'll move to the page and log in myself, too. You will see this page when you open the site to log into the site. You will see a blue button saying My Experiments. Or log in, or sign in. When you click on the button, you can move to the Workspace page of Azure ML Studio. If it's your first login, you can see this window. It is asking if you want to have a tour of Azure ML Studio. But you can choose Not now since we won't do that. When you first log in, you may see a screen similar to this. However, you won't have anything listed here. I have some lists because I already made some before. It is fine for you not to see any list. Let's start from here. Let me introduce the basic menus of Azure ML Studio. The blue ones on the left are the main menus. This experiment menu is the actual workspace, where we train our models and import data. The Web Services menu is where you can manage the model and review how much the model is used on the web once the model has been published. The Dataset menu is where we can upload our data. The Train Models menu is where you can manage your models after finishing the models. What kind of models I have, when the models were built, and so on. In the Setting menu, you can see the name of your workspace, the version you are using, and the size of memory I'm using out of the total 10 gigabytes. Other than those, if we need to work together with many other people, we can open the Users tab and invite others to co-work in the same workspace. So, these are the menus we have. This project's menu on the top is like a higher level folder. For Project A, we need this experiment, this web service, and this data. The project's menu contains all these menus like a folder. So, this is where you manage everything about your projects, such as experiments, data, results, and so on. We will perform many of our experiments in the laboratory, which has a conical flask icon. We need to create a new workspace for our practice. Before we do that, let's upload the 3 sets of data we talked about earlier. Go to the Dataset menu and the left menu bar. You will see your uploaded files for modeling here. For now, you won't see anything here because you haven't uploaded any files. You can use this new button at the bottom left to upload new data. Click on this, and you'll see a dark page like this. Click on From Local File, and you'll see a window saying, Upload a new data set. You can upload your data by clicking this Choose File button here. Those who have downloaded all the 3 practice files can click on Choose File and upload the files one at a time. You have to upload all the 3 files features .csv, train.csv, and stores.csv, but unfortunately you cannot upload them at once. Instead, you will need to upload one file at a time. If you choose the file, it will automatically recognize it as a CSV file here. Check the file type and click on the check button. Then it'll say it has been uploaded. While the first file is being uploaded, click again on New, from Local File, choose File, and upload the train.csv file. Check the file format as CSV. While we wait again, click on New, from Local File, choose File, and open the stores.csv file, and check. This will upload all of our files to the Azure Cloud Server. Upload time may vary depending on the data files you have. and the network environment you are in. Since our data size is not that big, the upload should be completed in a minute or so. I have my files all uploaded now. Make sure that all of the stores, train, and features.csv files are uploaded. We can directly import these sets of data uploaded like this for modeling. Then, let's go to the workspace. Go to the Experiments menu of the main menu. We will create a new experiment. We can click on the new menu like before, and then a dark window will slide up from the bottom. There are some materials we can choose from. The first one is a blank experiment. The others are samples of practices with uploaded data and training. It is similar to Excel or PowerPoint where you can choose from pre-formatted documents, as well as a blank document to start with. Azure ML Studio also provides a blank one and non-blank ones. We will create a blank experiment and build our own model step by step. Click on Blank Experiment, the first one. Then, we go to this screen. This is where we will be doing our practice. Let me briefly explain each component. This whole screen we are in is the workplace environment. The white area on the left side, where you can find saved datasets, trained models, transforms, etc. is called Module Category. All the functions we will be using from now are included in the modules. The module category is the space where each function module is located. When you open one, you can see several rectangles. Each rectangle represents each function. We will drag these modules to the center of the screen. This light gray area in the center is called Canvas. In general, we know a canvas as a space to draw something. We also call this area a canvas because we will build a model, as if we draw it in the canvas by dragging the modules to here and connecting them. This white part on the right is called a Properties window. When we choose data when using each module, or when we set each module's default, we can do it here in the Properties window. When I tell you to get a certain module from the module category to the canvas, you can find it here and drag it to the gray area. And when I say we will modify its properties, you can do it here in the right area.